Here's another video in the series Trig by Heart. In this one, we're going to talk about the radian and how to convert it between degrees and radians. Okay, you're probably pretty familiar with degrees. Degrees, remember, is a way to represent angles, and the entire circle would represent 360 degrees all the way around, right? A radian is kind of a different way to represent a circle. The way a radian works is it kind of like uses the radius as a way of measuring the circle, which seems kind of a natural way to do it if you don't have degrees and protractors. Okay, imagine back to what we did in the investigation. We took a circle, and then we took a piece of string that happened to be the length of the diameter, and we took that string and we put it around the circle to see how many times the string would go around the circle. What we discovered was that the string went around the circle almost or about 3 times. A little more than 3 times. It turns out that the string, the length of the diameter, goes around the circle 3.14 times. Okay? So, we're going to use the string as a way to represent how big of an angle it is. Okay? Now, instead of using the string that is length of the diameter, we're going to use a smaller string, which is going to be half the diameter, also known as the radius. Okay? So, if the blue string, which is the length of the diameter, went around the circle 3.14 times, how many times would the pink string, which is the length of the radius, go around the circle? It would go around the circle 6.28 times, or 2 pi times. Right? Okay. So, basically, a radian is one of the pink strings. Okay? So you can see how big a radian is. It's about that big. Okay? That's how big a radian is. Okay. So, how many radians are there in a complete circle? There are 6.28 radians. Okay? We can also say it's 2 pi radians. We usually give it in terms of pi because then it's exact. Alright. How many radians are there in half a circle? That would be 1 pi. Okay? So, 2 pi radians, which we represent with a C here, is equal to 360 degrees. The old 360 degrees. And 1 pi radian is equal to 180 degrees. Okay. This might be a good thing to memorize, that pi radians is 180 degrees. It's exactly 180 degrees. Okay, so now let's take the unit circle and we're going to divide it up into 12 sections. 12 sectors is what we call them. Okay, so you can see if we divide it into quarters here that each quarter has 3 sectors, and that makes sense, right? Because we divided the whole thing into 12 pieces. Okay. Now what we're going to do is we're going to figure out how many degrees in each one of these pieces. Well, if we divide 90 degrees into 3 equal pieces, then each piece is going to have 30 degrees, right? So each one of these sections is 30 degrees, right? How about if we do this? We're going to set a reference. This is the reference. This will be 0 degrees. Okay? So this is the 0 degree line. This is 30 degrees. This would be 60 degrees, right? Up to here it would be 60 degrees. And finally, up to here it would be 90 degrees. Right? And then what if we went even past that? Oops. Now we're going to go all the way to here. What would that be? Well, that would be 90 plus 30. It would be 120 degrees. And what if we went 30 past that? It would be 150 degrees. And what if we went 30 past that? Then it would be 180 degrees. right? That makes sense, right? Because it's half of the circle is 180 degrees. Okay, so now let's think. How many radians would each one of these be? Well, 30 degrees happens to be 1/6 of half the circle. So it would also be 1/6 of 180 degrees, or 1/6 of pi. Actually, 30 degrees corresponds to pi over 6 radians. Okay? What about 60 degrees? 60 degrees would correspond to pi over 3 radians. What about 90 degrees? 90 degrees would correspond to pi over half radians, right? Because 90 degrees is half of 180 degrees. So it's going to be pi over 2. 180 degrees is corresponding to pi itself, right? 60 degrees is 1/3 of pi, so it's going to be pi over 3. Okay? So what about 120 degrees? That would be pi over 2 plus pi over 6, which would be, let's see, I think we're going to have trouble with fractions maybe, but what if we convert both of these to pi something over 6? So pi over 2 would be 3 pi over 6. Pi over 6 would just be 1 pi over 6. That would be added together 4 pi over 6. So we could say that 120 degrees is going to be 4 pi over 6. Or we could also say 2/3 pi. Okay? What about 150 degrees? 150 degrees would be 5/6 pi. And finally, 180 degrees is pi. You can see you can count up even more. So the next step would be 7/6 pi. And the next step would be 8/6 pi. 8/6 pi was also known as 4/3 pi. Next step would be 9/6 pi. 9/6 pi, that's the same as 3/2 pi. What about the next step? The next step would be 10/6 pi. The next step would be 11/6 pi. And finally, 12/6 pi. Wait, 12/6 pi, that's 2 over pi. That's 2 pi. Right? That makes sense. 360 degrees is 2 pi. Okay? You can reduce some of these fractions, like 10/6, that reduces to 5/3, right? But if you want to leave it over 6, that's fine too. Okay, so we've just converted every single 30-degree interval to a different representation in radians, which always involves pi. Okay, finally, we're going to do the same thing with 45 degrees. 45 degrees would be this angle here, starting from the reference angle. The next angle would be 45 plus 45, 90 degrees. Makes sense, right? Next angle would be 90 degrees plus 45. It would be 135. Next one would be 135 plus 45, 180. Hey, what do you know? 180 degrees. That makes sense because it is half the circle. Then the next one's going to be 225. Next one's going to be 270 degrees. Next one's going to be 315. And finally, the next one's going to be 360 degrees. Right? Now, let's represent those as radians. So the first one is going to be, let's see, it's going to be 1/4 of pi, because pi, remember, is 180 degrees, and this is 1/4 of pi. So this would be pi over 4. The next one would be 2 times pi over 4, which can also be written pi over 2. The next one is going to be 3/4 pi. And the next one is going to be 4/4 pi, or just pi. And that makes sense. what we started with here was that pi is equal to 180 degrees. Next one is going to be 5/4 pi. And the next one's going to be 6/4 pi, 7/4 pi, and finally 8/4 pi, which happens to be the same as 2 pi. Now we've converted all the angles at intervals of 45 degrees to radians also. Okay? Now, I don't expect you to memorize these fractions here, but you can see that on the test, you can easily write these out. All you need to do is say, oh, okay, for 30 intervals of 30 degrees, I'm going to start out with 0, then pi over 6, then 2 pi over 6, then 3 pi over 6, then 4 pi over 6, then 5 pi over 6, then 6 pi over 6, right? And then you say, what angles do those correspond to? Well, that would be 0 degrees, 30 degrees, 60 degrees, 90 degrees, 120 degrees, and 150 degrees, right? You could just write out a table like this on the test. So you don't need to memorize it. You just need to figure out a way to recall it. Okay, what about for pi over 4? Same thing. You would say first one is 0, next one's pi over 4, next one's 2 pi over 4, next one's 3 pi over 4, next one's 4 pi over 4. What angles do these correspond to? 0 degrees, 45 degrees, 90 degrees, 135 degrees, and finally 180 degrees. Okay, that's it.